All right. So yesterday in class, we almost finished this. I mean, we finished it, but I had to go through some of the stuff quickly. So let me take this opportunity to make a video about it and explain those steps that that we went over fairly quickly last time. Okay. So if you remember, we have these loop equations. These are the position level loop equations. These are the velocity level loop equations, and we derive these in class. So what we went quickly over was one of the things we went quickly over was that with this definition of angles, this one and that one, and theta 3 right here, theta 4 right there, theta 5 right there. Yeah. I mentioned that the angular velocity of 2 in 0 was equal to theta 1 dot plus theta 2 dot in the z2 direction. Actually, to add to this, I can also mention that we had angular velocity of 1 in 0 is theta 1 dot z1. Angular velocity of 3 in 0 is equal to, let's see, theta 3 dot z3. And angular velocity of 4 in 0 was theta 4 dot plus theta 5 dot in the z4 direction. And angular velocity of 5 in 0 was equal to theta 5 dot in the z5 direction. Okay, let's compute these, okay? So why are these this way? So let me pull these guys down here. Okay, so let's do it once for angular velocity of 1 and 0. So how do we compute the angular velocity of 1 and 0? We said we can compute the skew symmetric matrix that is related to the angular velocity by using this formula. This was equal to, if you remember, R01 transpose times R01 dot. Yes? Now, if you look at our figure, I have not defined the axes here, but if we define the axes, x0, y0 pointing in the horizontal and vertical directions in the page, and x1 pointing along O1 to B, and y1 pointing perpendicular to that, such that the z1 axis comes out of the board towards us, then what we have is, sorry, what's going on here? Okay, what we have is R01 is equal to, if you remember, cosine of theta 1 minus sine of theta 1, 0, sine of theta 1, cosine of theta 1, 0, 0, 0, 1. That didn't work. Okay, yes? Now, what we can do now is, let me just see, delete that. What we can do now is actually compute this angular this thing here. So if I go ahead and do the calculation, well, let's see. Okay, let me write R01 transpose here. That's going to be cosine 1, sine 1, 0, minus sine 1, cosine 1, 0, 0, 0, 1. And R01 dot is going to be, you see, derivative of the 1, 1 element here is going to be minus sine 1 times theta 1 dot. Derivative of this guy here, 1, 2 element, is going to be minus cosine 1 theta 1 dot. Derivative of 0 is 0. Time derivative. These are all time derivatives, by the way, right? So let's see here. Derivative of sine 1 right there, yes, is is actually cosine 1 theta 1 dot. Derivative of cosine 1 here is minus sine 1 theta 1 dot. Yes. Derivative of 0 is 0. Oops, 0. Derivative of 3 1 element 0 here is 0. Similarly, derivative of 0 is 0. And the derivative of 1 here is also 0. Yes. Okay. So now we have these matrices right here. This, let's see, this one and that one. Yeah. We can actually go ahead and multiply them. Essentially apply this formula right there. So let me write it again here. Now compute it. R01 transpose R01 dot. Yeah. This is going to be cosine 1 sine 1 minus sine 1 cosine 1 0 0 0 0 1 times. By the way, I can write this. I can pull theta 1 dot out from this equation, right? So I can write this as minus sine 1 minus cosine 1 cosine 1 minus sine 1 0 0 0 0 0 times theta 1 dot. Yeah, it's just I don't have to write theta 1 dot 4 times. I'm just writing it 1 time, so it's kind of simplifies the amount of work, or reduces the amount of work we do. Okay, so back to this. I'm just writing the matrices together so I can do the matrix multiplication. So we'll do the matrix multiplication to find this 1 1 element. What do we do? This is this element times that element plus this element times that element plus this element times that element. Yes? So if I do that, it's going to be cosine theta 1 times minus sine theta 1 plus sine theta 1 times cosine theta 1, which makes 0, plus 0 times 0, 0. So this element here is 0. Okay, so let's compute this element, 1 2 element. It's going to be cosine theta, it's going to be this element here times that element there, plus that element times that element there, plus that element times that element right there. Yes? So if I do that, it's going to be cosine times minus cosine, which is minus cosine theta 1 squared, plus sine times minus sine. So it's going to be minus sine theta 1 squared. So minus cosine theta 1 squared minus sine theta 1 squared is equal to minus 1. Yes? So here again we do the same thing. Now cosine times 0 plus sine times 0 plus theta times, cosine theta 1 times 0, sine theta 1 times 0, and 0 times 0. Sum them up, you get 0. Okay, so this element right there is going to be negative sine theta 1 times negative sine theta 1 is sine theta 1 squared, plus cosine theta 1 times cosine theta 1, cosine theta 1 squared. So sine theta 1 squared plus cosine theta 1 squared, you get a 1. Okay, and now for this element, we do minus sine theta 1 squared times minus cosine theta 1, sorry, not squared, so scratch that, let me repeat that. For this element, I'm going to do minus sine theta 1 times minus cosine theta 1 plus cosine theta 1 times minus sine theta 1. They are going to cancel each other, and we're going to remain with a 0 right there. Okay, this will be 0, this will be 0, this will be 0, this will be 0. Okay, and of course all these things are multiplied by theta 1 dot. Yes, so this is the skew symmetric matrix. From the skew symmetric matrix, if you recall, we can create a 3×1 vector, which is going to look like this element is going to come from that. Yeah, that's 0. So it's going to be 0. This element here is going to come from that guy, which is also 0. And this element is going to come from this one. But if you remember, this one was the negative of this element. So that third element in this vector is going to be theta 1 dot. And if you remember, I told you that this operation right here always gives you the angular velocity expressed in this coordinate system. So this is going to be expressed in the first coordinate system. In other words, this is going to be equal to theta 1 dot in the z1 direction. Okay? So this is how we compute the angular velocity of 1 and 0. So essentially, we're going to do the same thing to compute the angular velocity of 2 and 0. Okay? So let's, and that was a little bit more tricky, I guess. Let's do that, okay? So if you recall, when the angles are relatively defined like these, what we have is that the rotation matrix of the second frame with respect to the 0th frame was equal to cosine theta 1 plus theta 2 minus sine theta 1 plus theta 2, sine theta 1 plus theta 2, and cosine theta 1 plus theta 2, and 0, 0, 0, 0, 1. Remember that. From here, I can immediately write the transpose of this matrix, right? Which is going to be cosine theta 1 plus theta 2, and these are going to switch signs. 0, 0, 0, 1. Okay. What is the time derivative of the rotation of this rotation matrix? Let's see. Okay, so what we're going to have to do is take the time derivative of each element here in this matrix. Take the time derivative of every element in this matrix, right? That's what we need to do. So, what's the time derivative of cosine of theta 1 plus theta 2? Well, we need to use the chain rule. Derivative of cosine is negative sine theta 1 plus theta 2, and the derivative of the inside of cosine, which is theta 1 plus theta 2. So it's times theta 1 dot plus theta 2 dot, you see. Yeah? So, so this element here is going to be minus sine theta 1 plus theta 2 times theta 1 dot plus theta 2 dot. Okay? Okay, let's look at the 1, 2 element. That's the derivative of minus sine theta 1 plus theta 2. So similarly, take the derivative of minus sine theta 1 plus theta 2. To take it, you must first take the derivative of sine, which is cosine, and then take the derivative of the inside, which is again theta 1 dot plus theta 2 dot, you see, yeah? So this is going to be minus cosine theta 1 plus theta 2 times theta 1 dot plus theta 2 dot. Derivative of 0 is 0. Derivative of sine theta 1 plus theta 2 is essentially the same thing as this, but without the minus sign. So this is going to be cosine theta 1 plus theta 2 times theta 1 dot plus theta 2 dot. And the derivative of cosine theta 1 plus theta 2 again is negative sine theta 1 plus theta 2 times theta 1 dot plus theta 2 dot. And the derivative of zeros are zeros, and derivative of 1 is 0. So you can see where theta 1 dot plus theta 2 dot is going to come from here. You can already see that. Okay, so now let us use the formula again. The skew symmetric matrix that corresponds to the angular velocity of 2 and 0, right? This is defined, by definition, this is equal to R02 transpose times R02 dot, and I've just computed those over here, so I'm just going to plug them in. R02 transpose looks like cosine 1 2 sine 1 2 minus sine 1 2 cosine 1 2 0 0 0 0 1, and R02 dot is going to be, you see, minus sine 1 2 minus cosine 1 2 cosine 1 2 and minus sine 1 2 0 0 0 0 0 times everything is multiplied by theta 1 dot plus theta 2 dot. Okay, very good. Okay, now we can just do the matrix multiplication like we did before. So the 1 1 element is going to be cosine times minus sine plus sine times cosine, so this is going to be 0. 1 2 element, cosine times minus cosine plus sine times minus sine, so minus 1. 0 1 0 0 0 0 0 and everything is multiplied by theta 1 dot plus theta 2 dot. Now from here, again, we can construct our angular velocity of 2 in 0 as 0, 0, theta 1 dot plus theta 2 dot. But again, remember, this is going to be in the second frame. In other words, I can write angular velocity of 2 in 0 as theta 1 dot plus theta 2 dot in the z2 direction, just like we did in class, pretty much, without going through this derivation. So what that shows us is that we just showed this is true and that is true. And you can use the same process to show yourself that these are also true as they are given here. And we use this in class to compute the final equations in the velocity level. All right, I'm going to end this video here. Hopefully this will be helpful to you when you're studying for the exam and understanding these concepts as well.